What is the Internet of Things? Is it hardware, software, or both? Well, chances are you already have it in your pocket. It might be on your wrist. Recently popular are fitness bands with accelerometers and gyroscopes to monitor our activities and heart rate. Now we have smartwatches which do all of that, play music, and answer messages. Smartphones and tablets have replaced maps, secretaries, alarm clocks, entertainment, and now they can control our homes, change the TV, the temperature, security, and lights all from your device. Our cars are even getting smarter with sensors to keep us safe. The Internet of Things is simply using technology to mimic the human experience and simplify life.
Hello everyone, welcome to Charlotte IoT. Tonight we have a special treat. It's lightning talks, and these are my favorite meetings of the year because you get to learn so much in like action-packed amount of time. And if you aren't interested in one, it'll be over in like 10 or 20 minutes, and it's the next action-packed one. So these meetings are just like totally incredible and awesome. And Charlotte IoT did incredible things last month in October. And for those of you who don't know Charlotte IoT, we're about 1,200 people. We've been doing this for about 3 years, and we do like epic things, and especially in the month of October, and I can't wait to show you some of the slides. But we're focused about learning, and we love to help others and to teach others, and we also love to learn ourselves. So this whole group is all about everybody helping each other learn, and we do lots of hackathons and things like that. And this board is like the most incredible board in Charlotte. And this is why Charlotte IoT rocks so hard. And Graham, he does all the facilities and orders the foods and just make sure everything goes off perfectly. Rob, he does our hands-on lab, and we just did one at the Maker Fair at Discovery Place. And just like a really great lab that everyone loved. And Joseph, he's streaming our videos, and it's like, we didn't even know we needed online videos, and now we stream every meeting, and we really love having that. And it's really cool because you can go home and you can like watch us over and over again, and it never gets old. And Mike, he's our awesome swag coordinator, and he's the reason why we have so much like incredible stuff, including this pile of photons right here. That's we always get incredible stuff from Hackster. And I'll talk about Hackster in just a little bit. Christoph, he coordinates big events like the Maker Fair, and he can't be here on Tuesday nights because he's like out of town every Tuesday night, but he still like helps out every chance he can. And Glenn, our social media wizard, he'll come down and talk in just a little bit. He's doing amazing things, helping our group grow and become like more awesome. And Jeremy, our civic hackathon leader, is just incredible. I can't wait to show you the slide on that. So our group is just like totally awesome. Glenn, can you come down and talk a little bit about social media and how we can make the group even like better?
All right, so Dan's got some cool giveaway stuff tonight. What are we giving away?
Oh yeah, we've got a cool Charlotte IoT shirt. And we also have 2 Nordic semiconductor boards. They look like Arduino boards. I'm sure that do RF really cool things, but some really nice stuff.
So tonight, and to be entered for the giveaway, I put up 2 pictures on Instagram and Facebook. The one with the 4 presenters, the best comment will win the t-shirt. Bonus points for sharing on Facebook. So hit the share button, let other people know about it. In the past, people have directly messaged the account. That doesn't really help us. So if you could comment directly on the post and share it, that will be the best for us. If you have content at home, if you have an IoT project at home and you want us to share it on our social, send a DM to those accounts, let me know, and then I can tag you and help promote you as well.
Awesome. Yeah.
If you have any other questions on how it works or if I can help you, just let me know. I'll do that.
Yeah. Thank you. So yeah, everyone, we want you to say like really great stuff, and we're going to be the judge. So if we don't think it's great, you won't win.
Maybe bonus points for Spooky Kitty. I should have mentioned that.
Yeah. And Joseph, he does our streaming video, and what he does for us, he can do for you too. He's got a production company, and he can do like intros to videos, he can do videos, he can do all this like amazing stuff that he does for Charlotteiot for you guys as well. So if you have projects at home or businesses that you need really cool intros, then please talk to Joseph about that. And we've got Slack and Twitter, and Mike is really good about if on Meetup you enter your profile information with your email account, then Mike will give you an invite to our Slack. And our Slack channel has, we got all kinds of Slack, other rooms or channels that everyone is talking in, and just it's really good collaboration. And our sponsors tonight, my company, Logical Advantage, and Graham, can you tell us some, I got a slide for you.
Oh, you do? Okay.
Yeah.
Oh, I got job openings. Anybody want a job? No. So I work for SnapAV. I don't know, 2.5, 3 years ago now, I met Dan, and we've been hosting it here. So just a real brief point on Snap. We are a manufacturer of audio video equipment, and I run a software team that is an IoT platform that allows us to remotely control all those products. And we're just up to about 1 million devices in the field in about 120,000 locations or so. So we were very interested in Charlotteiot, and I think we've had a great time over the last 4 years.
Great. We love the facilities and everything.
So welcome. Let me know if you have any questions. And I do have some job openings if anybody's looking, specifically server engineers and DevOps.
Yeah, sweet. And then Hackster.io is just like completely incredible. Mike's was our first ambassador, and they give us amazing swag, but on top of swag, they give us money. They give us $200, and we use that money largely to buy things for hackathons, for our civic hackathons and for workshops, and it's just been totally incredible. So if you guys could all tweet a little thank you to Hackster.io with Charlotteiot, and that way we'll keep the Hackster love coming our way with all this great swag. And a little commercial for my company. My company is Logical Advantage, and IoT is really important to us. We started the group about 3 years ago, Charlotteiot, and because we had like a whole bunch of really cool projects, and we just finished one for manufacturing that was completely epic. We've done talks here on it, but it was like so epic that Particle, the microcontroller company, just wrote up a case study on it. And they're like mentioned in Gartner all the time for being like really cool in IoT. Particle is like one of the most relevant, one of the most cool IoT companies. And so they picked our Logical Advantage case study to talk about industrial IoT and how to use that platform to drive like business, help you make better business decisions, which was just like really, really, really cool. And if you guys could help me out tonight, go to Particle's Twitter. It's Particle, just @Particle, and retweet their blog or the blog on this or the case study, one of those tweets, and that would be like really helpful, and we'll just spread the word out to everyone on how cool. And we're doing really cool things in Charlotte with microcontrollers and IoT, and in this project we're doing it with Azure IoT Hub, and we can do streaming analytics and visualize the data and some really cool things. Oh, I almost forgot something else just is amazing. If you guys have never bought any Particle devices, we just bought like a whole bunch here. Mike got us 14 of them for this month's Hackster money. But if you enter Logical 30 on their store, you'll get 30% off. And so I encourage everyone to get like not one, but get like 10 of them, because they're so cheap and they're so fun. And yeah, be like Mike and get 14 of them.
So special thanks to Particle for the discount code that they amplified our Hackster money by about $80 because of the Logical 30.
Yeah, rock on. Yeah, and they're so fun. And so I would encourage everyone to take advantage of this. Through the end of January, but go ahead and just take advantage now and keep on buying more through January. And we've done a whole bunch of other cool projects I'm not going to talk about, like Smart City, tracking millions of carts. racing and things like that. I'm going to move on to the Maker Faire, because at Discovery Place this year we did the Maker Faire, and it was pretty epic. We had 4 tables, and we had like tons of projects. Everyone brought their IoT stuff, and we showed people how to do things. And then Rob made this really amazing lab that just went over really well. And you did the lab, was it 2 times?
Yeah, we did 2 sessions, and we were standing room only.
Standing room only. And we learned from last year, because last year our lab was more complex, and it was more geared towards like makers and people who come to these meetings. And we get general population and younger kids, and so Rob geared it towards block programming and really engaged people on like how to learn and how to do things with like no experience at all. So thank you, Rob. That was like incredible. And Civic Hackathon. Jeremy, can you come up and tell us this amazing story?
So I want to say thanks first to LendingTree, where I work. They've been gracious enough to provide us some space and pizza the last 2 times. They're going to continue doing that. They've also been reaching out to their media contacts, and we've been starting to churn some media about the event. Kind of hoping that we can start working with maybe local hospitals or disabled groups to start teaching them that we can take these devices, and I mean, for less than $200, you can voice enable a TV for somebody who has limited mobility, and that's both very obtainable and very cool, but can provide such great freedoms for people. We did our hackathon again this Saturday. It was pretty amazing. We were chewing into remotes and doing all kinds of fun stuff. Mark was working on his lip sync project, which is just phenomenal. And just everyone who was there was just full of energy, and it was so great to see. We've delivered already to 1 person here in Charlotte, and we're getting ready to deliver to Mark. A pad that both heats and cools, kind of cool. And also hoping to send him a lip sync as well. And just a phenomenal thing to be part of. Really enjoy it myself, but it's really fun to see everyone, just all the energy that's there. If we're not here to help, I mean, what are we here for, So thanks a lot to Ben for being our inspiration. Dan for putting the first one together and keeping everything moving. Mark has been great inspiration. Mike's our EE guy. Mike, thank you. You're awesome. And everyone else that was there. So, amazing team.
Totally incredible. Yeah, nothing makes me prouder about Charlotte IoT than the civic hackathons and all the amazing thing that everyone is doing. And I also want to do a shout out to ChiliPad. They gave us a really expensive, really cool blanket that heats and cools. And we applied Alexa controls to it during the last hackathon. It's just really fun. GeekFest. Joseph, can you tell us about GeekFest?
Yeah.
Sorry to put you on the spot.
No, you're good. So GeekFest is CPCC's kind of like a mini maker fair in a way. The whole purpose of it is to inspire middle school and high school students. There's going to be about 400 of them at CPCC's Levine campus this Thursday. The way I explained it to like Jeremy and Robin as we were setting up what we're doing, they are just kindling and gasoline. All we're doing is giving them a spark. They have no idea what it is they want to be when they grow up, just like I still haven't figured out what I want to be when I grow up, and most of us haven't in here. Many of the jobs that these guys and girls will do not exist today. What's awesome is there are people in this room that are creating the groundwork for jobs that are going to exist 10 and 15 years from now. So we really need volunteers. I've had one reply. I have one person other than Jeremy, myself, and Dan who are coming from their work to volunteer. We're going to be doing labs similar to what we did at Maker Faire and doing a show and tell of like the Civic Hackathon. All we're doing is exciting these students about what kind of possibilities are out there. And I mean, for most of us in here, we were pretty much the outcast in high school because it was not chic to be geek when we were younger. It is a little chic now, but there's still a lot of those introverts that each and every one of us could identify with, and we want to give them that ounce of hope that there's something better after graduation, and they might not know that this career potential exists. So that's kind of what Geek Fest is about, is telling them it's okay to be a geek and
okay, it's like there's nothing better.
No, it's just okay. When you're in high school, it's just okay.
Yeah. So if you could, if you guys want to help volunteer on Thursday, that's this Thursday, please talk to Joseph after the meeting, and we could use some help. And on December 6th, we've got a big meeting on data. I love having meetings on data because we haven't had as many as we really should. But Hewlett-Packard, he's going to fly in town. I forget where he's from. I think he's out, Texas or California, somewhere way out west. And he's the chief architect for their data platform. And it should be a really great meeting, so everyone needs to come to that, and it'll be totally awesome. And now finally for our big event tonight. So with Lightning Talks, we've got 4 amazing talks. And David Simmons is our first talk. He traveled here from Raleigh, and I met him at one of the Riot events, and he's an IoT rock star. And he's been doing it for a long time, and it's like a big passion for him. And so I can't wait to listen and learn about Influx Data, which is a really cool time analytics, time streaming data platform for IoT and others things as well. David, please take it from here.
What is the Internet of Things? Is it hardware, software, or both? Well, chances are you already have it in your pocket. It might be on your wrist. Recently popular are fitness bands with accelerometers and gyroscopes to monitor our activities and heart rate. Now we have smartwatches which do all of that, play music, and they can answer messages. Smartphones and tablets have replaced maps, secretaries, alarm clocks, entertainment, and now they can control our homes, change the TV, the temperature, security, and lights all from your device. Our cars are even getting smarter with sensors to keep us safe. The Internet of Things is simply using technology to mimic the human experience and simplify life.
Great, so this is me. I'm David Simmons. I'm a developer evangelist, senior developer evangelist for Influx Data. Has anybody ever heard of InfluxDB, time series database? Anybody ever heard of Influx Data? Okay, I always get this response. People, yeah, I've heard of InfluxDB. Never heard of Influx Data. Influx Data is the company behind InfluxDB, okay? It's all open source, and I'll get to all of that. So first, come join us on our community site, ask questions. We've got all of the engineers, all of us from pretty much the entire company are on there answering questions all the time. If you want to go and download our software and build it yourself, that's our GitHub repository. All of this stuff is open source, so you can go and grab it and build it yourself. If you go to that URL, you'll get an invite to the InfluxDB channel on Gopher's Slack, okay? And on Twitter, we're InfluxDB. And I'm David GS IoT on Twitter as well. I think that was on the opening slide, but I kind of went past that. So what is Influx Data? We're about 4 years old, about 60 people in the company. What our founders discovered was that there's lots of databases out there built for all sorts of purposes, but there wasn't one really built for time series data. And so he went out and built a time series database from the ground up, designed it to do nothing but time series really well, okay? And one of his sort of guiding principles is this developer happiness, keep developers happy, make it easy to develop, easy to scale out, and time to awesome. We actually trademarked time to awesome because we like time to awesome, right? We got over 70,000 active servers and over 300 paying customers at this point. So it's actually getting really popular. And the reason there's a difference between the active servers and the customers is because it's free and open source. So you can go download it, install it, run it, play with it, do what you want with it, right? This is what I was saying about specialized data platforms, right? Oracle for relational data, table-based relational data. Elasticsearch for documents. There's all sorts of document databases out there, right? There's Mongo, there's Couchbase, there's a whole bunch of them out there. Big data, you've got Hadoop, there's a bunch of those as well, but none of those really do time series data. Time series data is kind of special in that way, right? And that's where we come in for events and time series. You were talking about DevOps, right? We're huge in DevOps. DevOps folks love us. And by the way, I'm hiring too. We're hiring Influx Data. So go check out our careers page and come join us. Time series is different, especially when it comes to IoT because of the huge volumes of data, right? So I've got a little demo here on the table that streams temperature and humidity and light and a couple of other things once a second to a database, right? Now, just one of them, that's not too much. What, 86,000 seconds in a day, right? But I have 10 of them. And that's even not very many of those. So in just over a day, I overran my data plan with Particle because they give you 1 million free messages a month. And 864,000 messages later in a day, it was not too long after that I overran my data plan, right? There's huge amounts of data, all right? This is our whole stack. We call it the tick stack, right? There's Telegraph, which is our ingestion engine. It's a really high performance plugin based ingestion engine. So we've got over 100 plugins for all kinds of stuff. Most relevant to IoT are things like MQTT, RabbitMQ, things like that. So you can basically just point this thing at your existing MQTT broker and it will start pulling in data, right? The middle of it all, the I in the tick stack is InfluxDB. That's our database storage engine, right? The C is Chronograph. That's our visualization front end. And I'm going to sort of show you most of these parts as I go through this. And the last is Capacitor, which is our event engine for notifications, things like that. So I always say this about IoT data. If it's not actionable, why are you collecting it, right? And I'm not talking about acting on the data, yesterday's data today, right? You've missed it by then. If it's yesterday's data and you're just starting to look at it and act on it, you've missed it. IoT data is now, right? It's stuff coming in now. It's stuff happening now that I need to know about and I need to act on now. Relational databases, I mean, you can make a relational database do this stuff. You can make it do it. It probably won't perform as well. In fact, I'm sure it won't perform as well. It's going to be a lot of work, a lot of maintenance, a lot of headache, because it's not designed for time series. It's designed for transactions and updates and things like that, relational data. Document-based databases, again, they're designed for something special. They're designed for document-based storage, query, and retrieval, right? IoT data is not document data for the most part. Time series data is a different thing. It's data over time, right? Stock prices. Stock prices are time series data. Price of a stock at a given time. And I stream that, and I get my stock price every half a second from wherever I'm getting my stock prices from, and I'm storing it someplace. That's time series data, right? Event data, like DevOps data. That's all event data. What's my CPU usage at this time? What's my, what's going on at this time? And sensor readings, temperature at time. That is IoT data, is time series data. It's a sensor reading at time. It's an event at a time, right? That's why IoT data is time series data, right? And that little cell over there is actually a graph from our chronograph front end of graphing some real-time temperature data, right? So how do you get data in? There's a bunch of different ways to get data into InfluxDB. I told you about Telegraph, the plug-in based ingestion engine, right? Really highly efficient, takes care of scheduling and batching and avoids a whole bunch of conflicts and things like that, right? You can ingest very large amounts of data through that, okay? Now, I'm running a small droplet on DigitalOcean, running a Telegraph instance, and again, I was sending it just under a million data points a day, and it did not even break a sweat, right? It's really easy to deploy. I can deploy all of the Influx stack on my laptop, all up and running in, well, the last time I did it and actually did a screen capture on it, I think it was 4 minutes and 30 seconds, a total of 8 commands to have it installed, up, running, and a dashboard that was monitoring my entire laptop, CPU, disk, network, everything else, right? And I can show you that dashboard. It's like, it's stupid easy, right? That's why we trademark time to awesome, because it is just stupid easy to do, right? And you get your dashboards. The easiest way to get data in is what we call line protocol. It's a really simple, it's an HTTP post to the database URL, which is the server that my database is running on, and it defaults to port 8086. And so I can send a post with my measurement, any tags for my data that I want to send, my data field and its value, and a timestamp. And I can put all my readings together in one simple post. So that's what I do with my box here, which is taking a bunch of readings. I just string them all together and stuff them all in at once. One simple call, right? And this table tells you what's optional and what's required. The measurement is kind of required. That's what you're storing, right? If you don't want to tag your data, you don't have to tag your data. But it makes it easier for you to query your data later if you're adding tags to it, right? The field set is required. You got to have something that you're storing, right? And the timestamp, oddly enough, is not required. If you don't send the timestamp from your data, the database will timestamp it for you, right? And if you're not sending it directly to the database, but you're sending it to Telegraph, you can have Telegraph timestamp it for you as well. Or you can send the timestamp coming straight off your device. Timestamps are Unix, timestamps in milliseconds since the epoch, right? And you can go to millisecond, second, or minute granularity on that, and you can specify that when you stick it in there, right? Telegraph plugins are a really easy way to go. There's over 100 of them, and there's a list there at our GitHub repository of all the plugins. Turns out they're really easy to write as well. the bottom, there's a new plugin for Particle's platform. And that's because I wrote it, and I wrote it in like a day, and it's written in Go, and I don't write Go. So it's really not that hard to write your own plugin. But that one's coming out in the next release, I think. So now you can send your data straight from Particle's cloud platform into InfluxDB with pretty much no effort. Right? Did anybody go to All Things Open up in Raleigh? Did you stay for the demo night and see any of the talks? Sarah Cooper from AWS IoT Solutions, she's a rock star. But that's my favorite quote from her. The more simple your data, the more complex the analysis you can run, right? And the reverse is also true. The more complex your data, the more simple your analysis is going to be. And that's one of the nice things about time series data is it's pretty simple, right? It's measurement at time. So I was putting together this demo, and I built this little dashboard pretty quickly, which is humidity, temperature, a couple of light readings, and name this graph. Actually, that's atmospheric pressure. I just forgot to name it. And when I was doing that, I was sitting at my desk in my office. I work from home, and I'm sitting at my desk, and I've got this thing running, and I captured the screen right when it happened because it was a real aha moment for me, right? So the pressure, I'm sitting there, and the pressure just starts to dive. I'm like, what is going on? Is there something wrong with the sensor? When the sensor goes bad, the temperature in my office drops to minus 217 degrees. So it gets really cold. So I was wondering if the pressure sensor was dying. And just as I'm wondering this, my wife calls from downstairs and says, you should come see the news. A tornado just went by a mile from here. Well, OK, so that explains the temperature, the pressure drop pretty easily. But then I'm looking at the spike, the temperature going up and down and up and down and up and down. I'm like, what is going on? Why is the temperature bouncing between 75 and 77.5? And if you notice, the humidity's kind of doing a bounce at the same rate. And as I'm sitting there watching this and wondering what's going on, it's just hitting that last peak up there, and the air conditioner comes on, and it starts to drop. I'm like, oh, that's it. So now I don't have to put a sensor on my air conditioner, right? I can monitor my air conditioner by monitoring the temperature going up and down. Turns out about a month ago, the air conditioner died, and so now it doesn't go up and down anymore. It just goes straight up during the day, which makes things in my office really, really uncomfortable. And that's why I say this. It's amazing what you can discover when you can see your data. When you can see what's going on with your data. If that was just flying by on a screen in numbers flying by, I never would have caught that. I never would have gotten that. But I'm watching it in the graphical form, and I can see that happening, and now I can see what's going on in my office, right? So there's where you can get InfluxDB. You can download Telegraph, InfluxDB, Chronograph, and Capacitor. If you're on Mac OS, you can install it via Brew. It's already in Brew, and you just do Brew install InfluxDB, Brew install Chronograph, right? And then Brew services InfluxDB, and it starts and it runs, and you're ready to go. So I'm going to do a little demo here. It wasn't working when I was talking to Dan earlier, but it seems to be working now. So I built these, oh, nope, it died. We need power. All right, I'm gonna take it over here and plug it into my laptop.
The black one has power.
That's all right. I'll plug it in over here. There we go. So this thing's got to find itself and orient itself. And this thing's got to All right, so this is a particle photon in this box, and there's some sensors on top. There's a light sensor that does ambient light and infrared and measures lux. There's this little Bosch sensor that does temperature, pressure, and humidity, right? And so this thing is now streaming data out to my InfluxDB instance. And this thing is actually a little Wemos with an LED shield in a 3D printed box with a ping pong ball on top. Okay? And this thing is not in any way actually, though they're plugged into the same USB, it's not actually connected to this. This is actually connected to an MQTT instance, right? So it's getting data from MQTT. And now, so here's my dashboard of all this data coming in real time off this sensor. The one up there, the max temperature this month is 91.15. At one point, it was like 186 because the sensor went nuts and recorded some wild temperature of 186. And so, but I'm getting past my data anomalies now. So we can see that when the sensor died, when that battery died and quit powering the sensor, so it's only been getting data for a little bit. And as I go over the data, you can see in the little box down here, you probably can't read it, but it tells you what the actual readings are, right? So you can actually drill down into your data right there. And if I cover it up, the light sensor should drop. There we go. Light values just bottomed out, right? Now, I told you about capacitor, which is doing this alerting, right?
Maybe we can get the lights turned off. I mean, we're struggling with the...
Are you? Well, most of that's not going to matter now because I'm gonna deal with this little guy.
Is that better?
Yeah. Okay. So there you can see over there where I covered up the light sensor, values dropped and then they popped right back up. So this is real-time data. This is actually coming off of here right now. And I've got this guy. Hold on. I've got a Node-RED server running, and it's dealing with this. So I told you about capacitor, right? So capacitor is monitoring the temperature, and whenever the temperature changes by more than about 0.2 of a degree, it sends an alert. And it sends an alert to that readings node, which extracts the temperature from it and changes the color of the ball, so that I can tell just by looking at the ball whether it's hot or cold or whatever. So here, we'll go back to the dashboard so you can actually see the temperature start to go up. Oh, there we go, got a nice spike. So the hue of the ball's changing. It's getting hotter. If I can get it above 90, it'll turn red. Yeah, I know, right? It's a good thing it's not a gas sensor, too. So, in all fairness, this is actually, all of this is going all over the internet, okay? My cloud instance of my database is running in the Amazon US West. My Telegraph instance is running on DigitalOcean in their East Coast data center. Okay. What else am I running? The Node-RED is running actually in a data center in Fayetteville. And the MQTT server for this guy is actually running at IBM in Sheffield, England. Right? Still performs pretty well. So every time the temperature changes, capacitor is monitoring that incoming data in real time, and every time that temperature changes, it notifies and my ball changes color. And you can see in real time my graph went up, and it started to come back down. And I'm back to my nice 77, 75 degree blue. Changes the ball only changes a color hue every degree, right? So that's kind of what you can do. This whole project took me about a day to build the sensors. And in fact, I have a blog post up where you can go and watch a time lapse of me building all 10 sensors, from soldering ribbon cables on and building the boxes and get them all together. So that actually took me about a day and a half to put 10 sensors together. The code took me half a day, right? And this I got from a buddy of mine at IBM, and I'm in the process of about to build a whole bunch more of these. Really simple, straightforward to put it together. And again, the getting the tick stack installed was dead simple as well, and I was just able to start streaming data.
Did your buddy get that from Watson?
From this? He actually built it by hand. He just sent me the 3D printing file for printing the box so I can start printing my own. And I've got a bunch of ping pong balls left over from the guys at Mythbusters who gave me like 10,000 of them. Oh, I'm not kidding. I'm not kidding. You remember? Does anybody remember the episode where they refloated a sailboat with ping pong balls?
Yep.
Yeah, they saved all those ping pong balls. They gave me a trash bag full of them. They smell like Monterey Bay. It's awesome. So I installed it on my local machine, right? I told you to install it on my local machine. This is my local machine. This is my laptop right now with, various, I'm monitoring the number of processors, the number of processes, active system processes, user processes, bunch of stuff, right? So this is, in this upper one, is the mean processes running. Over here, oh, it's the same thing. Down here, I've got system usage versus user usage, right? So the light blue is the system, and the dark blue is user. Right? And over here, I've got memory used percentage. This all just started working out of the box, right? It was just, I turned it on, and Telegraph started collecting all this stuff, and I went, and with about 6 clicks, I had a dashboard that was giving me all this data, right? So it's pretty useful, especially for time series data, and it's really easy to do. And for IoT projects, it's fantastic. Dan said I've been doing IoT for a while. I've been doing IoT for like over a dozen years. And I always ask the question of people who are doing I'm deploying an IoT project. Great, where are you storing your data? Anybody doing an IoT project? Where are you storing your data?
Azure.
Yeah, right? Now that you've got Azure, right? A few years ago, the answer was mumble, analytics, right? Because there really wasn't a great place to store your data. There wasn't a place to do that. You can store it in Azure. You can store it yourself. You can host it yourself. I've also run this whole thing, the whole tick stack, on an Arctic 520. Which is an embeddable gateway. It's about that big, right? And I've run the whole thing, the database, the telegraph, capacitor, and chronograph on that little gateway. So it's possible to do a bunch of that stuff. And the amount of stuff you can do with telegraph and capacitor is kind of, I'm about 3 months into this, and I don't even have the first clue about all the stuff I can do with it, right? You can downsample your data. You can do calculations on your data in real time and store them back into the database and then have a dashboard to visualize that, right? You can have Telegraph send your data to multiple places. You can have Telegraph collect your data from multiple data streams and then send it all to the same database. Right. My next plan is to put telegraph on my Arctic 520 and use it to collect the data for a whole bunch of local sensors and have a little visualization running on that box, but then downsample the data and send it further up to my cloud instance where I can do some more analytics on it. You guys got questions? I've just been like railing at you as fast as I can to get into my 20 minutes. Yeah.
The first time I heard about time series data was in a talk with R and Markdown and a time series DB. And the idea was that this was really important to accounting and a fiduciary in order to regenerate reports. Is that the same context for InfluxDB?
I'm not quite sure why time series data would be important to a fiduciary unless they're like waiting for you to die and it's like, now, kind of thing. But
I think the U.S. government comes and asks them to generate the exact same document that they generated on a particular date.
Yeah, I'm not sure. That's probably not specifically time series, right? Time series is really good for the two things that I know that time series is really good at are DevOps, so server monitoring, and IoT data, right?
What about web data?
What kind of web data?
Conversion rates. People come in, people go out.
Yep. And in fact, there's a plugin for Telegraph that is an Apache log parser, right? And in fact, was it late last week or early this week, I posted a blog on how we are using, I am using InfluxDB and InfluxData to monitor the engagement on our community sites, right? By number of new users, number of new posts, number of new topics, number of, all kinds of stuff that go on. And I'm monitoring that because I was always asked for those statistics by my boss, and I got tired of going in and looking them up every time because that's why we have computers. So I started stuffing it all into InfluxDB, and now I can go and look and see at any given time what the number of page views is, what the number of topics created over today, the last 7 days, the last 30 days, right? All that statistical stuff is now in a database. And it just runs, and I don't have to worry about it anymore. And I had another dashboard I was going to show you, which is I have another sensor that runs in my office, and you're going to get to see just how bloody hot it gets in my office. And I also have another data source that I started pulling data in from the National Weather Service. So I started pulling their live feed from their RDU weather station, right? So their temperature, humidity, pressure, right? All the same stuff that I've got going on my other dashboard. So I could compare what it was like at my house to what the National Weather Service was saying. Turns out they're really pretty close other than the temperature because, they're measuring outside and I'm measuring inside. But that's another way to sort of augment your data is I can start pulling in data from a bunch of different data sources into the same place and put it on the same dashboard so I can see what's going on. I can look at what's going on from a bunch of different angles. Yeah?
How much data you can store in the DB?
How big is your...
how much data?
How much room you got to store stuff?
Yeah, but there is a limitation for like a processing, demo, like that's why we have like Teradata or like big data, this kind of stuff.
Right.
So.
One of the great things about InfluxData is it gives you the ability to put data retention policies on your data, right? So IoT data is great, and you got to know, as I said, it's got to be now and it's got to be actionable, right? But I'm really not so interested in the second-by-second temperature readings from my office a month ago, right? I can downsample that a bit and keep that, right? So that I have a historical record, but I don't need 86,000 data points a day from my office from 6 months ago. That's not actionable data anymore, right? So I can set a retention policy that I expire that data, And I can, with capacitor, I can do continuous queries on that data, and I can basically downsample my old data before it expires and put it back in the database as, sort of downsampled data, so that I can go back and I can see that, yeah, I'm keeping 5 readings a day or 10 readings a day or a reading an hour, right, from 6 months ago. And I'm keeping a reading every 10 minutes from 4 months ago. And I'm keeping a reading every minute for the last 3 months. And I'm keeping a reading every second for the last maybe week or two. Because other than that, it's just why, right? It's no longer relevant. It's no longer actionable. It's past its use by date. Its sell by date is over. So I can keep it around so that I have historical record of what's going on, but I don't need that really fine-grained data anymore.
Yeah, but my question was, Bill, was on the like you mentioned like a stock market, like a pattern stuff, that they tend to go like 100 years if they could. And so same thing with the weather. I mean, they want to disassemble the weather patterns. That's what I'm asking. For your database, is it possible to store like 100 years of data?
Yep.
Okay.
Yep.
That was the question.
You can ingest, 500 million rows into it in a very short amount of time.
And how big is in the memories? I mean, terabytes.
That all depends on the data and what the series cardinality is and what your tags are and what your data is and how fine-grained it is. The short answer is it depends, right? It all depends on what your data is. And one of the things I didn't say that I really like about this as well is I'm about to add some new sensors to these things, right? I'm about to add CO2 sensors to these things. And I'm going to just update the box to start sending CO2 data. I don't have to touch my database. I can start sending a new sensor reading, and it'll just get written in, and it'll be there. I don't have to go adjust the schema and do any of that other sort of database management stuff, right? And if I have sensors that are not sending that CO2 data, so what? That doesn't hurt the data, it doesn't hurt the database. Those sensors will continue to store the data that they're sending, and the new ones that have the CO2 sensors will now store an extra reading, and everybody's happy. You had a question?
It sounds like this is really great for ingestion and storing the data. You were talking a little bit about sort of making it actionable, and I think that's where it comes, where like you writing queries that's going to hit that database to sort of interpret it, and then you build in logic for what you want to happen. Basically.
Yes.
Is that correct? Does InfluxDB have any of this
yes.
analysis tools and things like ARIMA to sort of monitor and make forecast where it's heading?
Well, for forecasting where it's heading, not so much, but we have continuous queries that you can run on the data, and Capacitor actually has a scripting language called TickScript. And so you can write scripts in TickScript to do a whole bunch of stuff, like alerts, right? So that's how this works, right? Capacitor is actually sending an alert to the URL that is my Node-RED instance to change this. Now, there's a whole bunch of different alerts that I can write and I can set. One of the really useful ones is a dead man alert, so that if a device isn't sending data for a definable period of time, somebody needs to know about that, right? So you can hook it up to, well, one of the folks in my office hooked it up to Slack, which was really unfortunate for us on Slack because it got a lot of notices. You can hook it up to PagerDuty. There's a whole bunch of places that are sort of built in that you can hook it up to, or you can just send it to a URL and write a little, Node program to deal with it how you want, right? Any other questions? All right, you guys that ask questions are the winners. You get socks. No, seriously, I've got these really cool Influx Data socks. So you guys that ask questions get socks. Thanks.
What is the Internet of Things? Is it hardware, software, or both? Well, chances are you already have it in your pocket. It might be on your wrist. Recently popular are fitness bands with accelerometers and gyroscopes to monitor our activities and heart rate. Now we have smartwatches which do all of that, play music, and they can answer messages. Smartphones and tablets have replaced maps, secretaries, alarm clocks, entertainment, and now they can control our homes, change the TV, the temperature, security, and lights all from your device. Our cars are even getting smarter with sensors to keep us safe. The Internet of Things is simply using technology to mimic.
All right. How's everyone doing tonight? So when you guys asked, or we took a vote, I guess, last month on what Rob was going to talk about, the votes were decidedly towards a HoloLens-based presentation. So this is going to be decidedly less formal than our previous one here. So feel free to stop me, interrupt me if you have any questions. Most of you have heard me talk or seen me talk before, so. I'm fairly sure you guys are well familiar with my presentation style here at this point. But the basis of this project actually probably started about a year or so ago when I saw some of the stuff that Dan was doing to scare kids in the neighborhood. And why I say that is I've been working with a bunch of mixed reality, augmented reality, virtual reality, depending on what buzzword you want to specifically use, for about a year and a half now. I run a gaming meetup once a month, similarly to this, where we focus on a lot of game development stuff using Unity and whatnot. And when Dan was, showing off his flaming pumpkins and all that, one of the thoughts I had is, hey, I've got this, at the time, new device, HoloLens here. How can I use that to scare people? And so what I ultimately wanted to do was essentially create my own haunted house within my house using the HoloLens. As you walk through, stuff would kind of jump out at you, and the jump scare type stuff as well. But just having the jump scare stuff wasn't necessarily enough.
Sorry, that was my fault.
Do you need me to wait?
Oh, wait, check, see if it went to sleep.
It went to sleep. So, no, not your fault. So in addition to doing just like regular jump scare type stuff, I wanted to actually use some of the capabilities within the device itself to be able to control stuff in my house, right? So as you got close to lights, as you got close to stuff, I could utilize the board, such as in this case Raspberry Pi, and Bluetooth, OpenCV, and a handful of different technologies to actually not only project holograms and images into the view of the user, but actually also really take the concept of mixed reality and have the device control physical objects in my house. So where do I start? So the first things were most of the development for HoloLens uses Unity, and unfortunately, how many people have used Unity, heard of Unity, familiar with Unity? A couple of folks in here. For those that haven't used it a lot, its support for .NET is based on the Mono framework, and it's very, very old version of the Mono framework. So utilizing stuff like the nice and easy 2 lines of code Azure libraries was out the window. And everything that I started with was writing my own services, running on a computer, just doing simple HTTP REST calls to the service on my computer, and then basically proxying those up to Azure to actually control the Raspberry Pi. That to me was a very dirty, ugly solution, not something that I wanted to actually do. So over the past year, I've been kind of refining it, and since I can't have Halloween every day of the year, started thinking, what other stuff can I control, and how can I make this a legitimate use around the house without getting killed for tinkering with stuff all the time. So what I decided to do is, okay, well, let me just, and for the purposes of tonight's demo, how can I just kind of demo and show off, just controlling a simple light with the HoloLens. So where this actually started is within the past 4 months, I think it is, 6 months or so, Azure has actually added some functionality to actually call direct methods on client applications, which has actually made life a lot easier. Before it was kind of like a poll model, constantly seeing, hey, do I have a message, and then act upon it. Now I can actually just register my method directly from the device, and then from anywhere I can actually just call that method on any of my devices and actually go ahead and control it. And so what I did is got that up and working first, just using some simple JSON. So we'll just kind of just show that working here quickly. And that is a way that I can cheat and get my device in the state that I want to start at. So you can just basically see, hey, it's working. I can turn on the device remotely pretty much from anywhere. I can actually connect to the internet and connect to my Azure portal. So because HoloLens can be a little bit more difficult, so how many people, just before I jump the gun here, know what the HoloLens is, heard of the HoloLens? This is the first time you've seen it, not the first time you've seen it?
Second question.
How many people here have seen the HoloLens before, knows what it is? Okay, how many people this is the first time ever hearing about the device? Okay, so what the HoloLens actually is, it's a device developed by Microsoft. It was released back in June-ish of last year. It's the world's really first and only fully untethered holographic computer. They developed a lot of it from scratch. You have a lot of stuff like the Oculus Rift, the Vive, Google Cardboard, a whole bunch of other devices. Most of those are typically tethered to a computer or some other device to actually do what's known as mostly a virtual reality experience, in that they are fully controlling the experience that you see. What this does instead is it actually is known as more of an augmented reality device. So what it will do is it will actually take sensory data through, totally lost my train of thought here. Basically take sensory data and actually augment the experience that you're actually seeing through the visor itself. So what we can do is we can use spatial mapping. The cameras on the front of the device are able to actually map out surfaces and basically have holograms and stuff interact with information in the room. The cool thing about it too is once I go ahead and I map this room, if I place holograms or if I place things in this room, I can leave, I can come back a couple weeks later. All of that information is still going to be stored on the device, and anything that I placed in this room is still going to be available to it at a later point in time. So with that being said, one of the first challenges that I actually had before I wanted to actually sit and do this is I am not a 3D artist, and everything that you use with this, you had to kind of take the concept of working in a 2D world, because now you can fully interact with 3D objects that are placed in your environment. So I thought, one of the first things that I would actually focus on is writing a game that actually goes through and calls my Azure IoT hub. So in order to show that, let's give it a second here to launch. So what I've gone ahead and done is just basically have a real simple room. It's got a light sitting on the middle of a table there, and we went ahead and modeled this out. And what I want to do is show you that, hey, for those that were actually at the Maker Faire, you've probably already seen this already, but with the simple light on the screen, I can go ahead and I can control it, turn off the light in the game. The light in real life goes off. If I want to go ahead and turn it back on, the light in the game, the light in real life will be controlled as if in a game. So the idea being that I can, I'm getting outside of my contained experience and trying to interact with real world stuff as well. So now that I had that up and working, I was pretty excited about that, because that took presumably longer than it should. The next step for me was actually getting this to work with the actual HoloLens itself. For those that haven't done UWP development yet, one of the things that we're limited to with this is all applications have to be built on the Universal Windows platform. So you're limited from a .NET perspective as to the stuff that is actually supported both by the UWP platform as well as what Unity limits you to in terms of its mono support. So I'm going to put this on, look a little bit ridiculous here for a second, but what I am going to do is I'm going to actually stream out what I see. Go ahead, Mike.
Is that going to change with standard 2.0?
So UWP with the Fall Creators Update actually will support .NET Standard 2.0. So once this gets caught up to that and updated, then you will be able to. All right. So we're going to try and see how this works out here. And we could possibly figure some things out here if people want to take a look at this a little bit later.
You pay $3,000 for this?
Yes, absolutely.
And the Oculus are
What was that?
100, I guess, or so?
Oculus, I want to say right now is about 600, or depending on which one you go with. But I mean, it is a different device in general, right? Oculus being a virtual reality device versus this being your untethered augmented reality device. All right. So it's going to be about 5 to 6 second delay, but hopefully it will come up here. Come on. There we go. All right.
We lost it.
Yeah, that's unfortunate.
Do you have F-Flux?
What was that?
Your color for going to sleep, can you kill it?
Color for going to sleep.
Yeah,
a blue light filter.
Everything's pink.
it prevents your eyes from.
Oh, I don't remember what the setting is.
Everybody wake up.
Come on. All right. So for some reason, when I walk away, it's Come on.
Is it because the mouse is staying over the preview button, stop live preview button?
All right, so what you can see here is I have a sample here. We'll put it on the table in front of you guys. That doesn't help you, for the camera does it. So hopefully you can see on the desk in front of there, even though it's not there in real life, I'm actually staring at a notepad with a, where am I? In your way? All right. A notepad with a red light there. Come on. Come back up?
Yeah.
Okay, so you can see the hologram right there, and then similarly, as I turn it on and off. So now the cool thing that I've actually gone ahead and done, I don't have it here, but I do actually have like the Philips Hue lights as well at home. So what I've done is I've taken that and I've taken some NeoPixels and basically just have a little barcode on the, man, this is killing me here. Let me try this other one here instead, see if it works a little bit better.
What's the connection between the HoloLens and the computer?
My cell phone. See if that's working a little bit better. Hopefully that'll keep up a little bit better. So what I've actually done is actually put like barcodes and stuff like that on some of the devices in the house so that using the OpenCV libraries with the HoloLens here, I can actually recognize a specific device type and then be able to get context for what that device is. So for example, for like a NeoPixel or the Hue lights, when I actually click on that, I can actually bring up a menu that not only turns it on or off, but also allows me to have a holographic color selector as well, so that I can actually go through and change that as well. So, I guess questions at this point, or anything I can answer for you about this?
You had mentioned that it stores, so you could go away and come back. What is the kind of limit on that? Where you start to lose more?
I mean, it's all based on hard drive space. These things have, I forget, it's either 64 gigs or 128 gigs of flash memory. So if you have a ton of stuff, you obviously don't want to, you can go through and delete your spaces, so you don't have to go through and remember that. But you know, I've not filled it up yet and taken it all over the place.
Well, Rob, is there some kind of coordinate system that's involved with it too, to know where things are at?
Nope. So it uses, there's actually locatable cameras in the front headband here, and it basically is constantly scanning the room. What you can actually see here, am I still good? When I go ahead and move this, you can see the triangles come up. So for example, we can see what Joseph looks like to the spatial mapping as well. And what it will do is it will just constantly look around that, gather that information, save that information, so it can determine, you know, what does the room look like when you come back in. It is possible to trick it. Let's say you have two conference rooms that look almost near identical. When you go into those, if they're laid out the same, it will determine it as being the same, but it does use stuff too, like the Wi-Fi signal strength and SSIDs and all that as well to try and identify unique places.
Is it a way to tag the items?
I'm sorry?
Is there the way to like put the tags on the items, for example, or person, like for example, there is a bunch of people sitting and you put the names there?
Yeah, so I actually, not on this, I had a version that I deleted that would actually use cognitive services to actually go through and do emotion detection. So what I could do is I could look at, say, Joseph and say, you know, take picture, right? And what it would do is it would take his face, recognize his face, send it out to the Cortana Cognitive Services, and then bring it back and basically say, you know, happy, sad, angry, that type of stuff. And then it would actually kind of do kind of like the RoboCop type layouts and stuff like that to store information about them and do just general facial recognition and image recognition and processing.
And it's all done through the headset, or you have external storage?
I mean, the headset, you know, depending on what application you write, right? It can do stuff like use like OpenCV to do some sort of basic image recognition in that, but you can use like the Azure services and stuff like that to actually do additional processing and stuff like that as well.
So rather than buy floor mats from WeatherTech, you can just print your own with those glasses and scan your.
So there is some ability to do like motion capture and scanning and stuff like that, depending on how much detail you need. I want to say it can get up to. I forget what the exact resolution that it can actually get to per meter, but you can actually do general room scanning and area scanning with it.
How long does the battery last in these?
Depending on how intense what you're actually doing, but for general use, you can easily use it 4 to 5 hours without a problem.
And is it controlled by voice?
Yeah, so for example, here, toggle light. Oops, I get it.
She froze.
What's that?
Yeah, the picture is frozen.
And
but can you connect like external devices, like the keyboard, mouse, whatever?
So there is a, let me try this again, toggle light. Let's try again. Maybe that's not the command. Toggle light. There we go. It does have Bluetooth on it, so you can do stuff. There is actually a Bluetooth clicker that comes with it. That if you're trying to do keyboard input and stuff like that, makes it a little bit easier to move like the reticle around and all that. And through like this app, this is terrible. So through here, there's the external keyboard that you can use through like an external app or whatever to help make some input a little bit easier, because doing stuff like username and password through air tapping is not exactly fun.
Exactly.
So it's a Windows 10 computer that's in it?
Yep. So it's running the which one would be Creators Update, I believe, is on this right now.
Is it just as easy as making a UWP app and hosting it pretty much, or do you have to do some special stuff?
So yeah, it's basically any UWP app will run. You kind of have two different kinds. If you have just a standard UWP app, it would be treated similar to like IE, or like, for example, Netflix. You can watch Netflix of this and see a video, and pretty much any screen you want, it will be in 2D. If you actually want to do 3D, that's primarily done through Unity, that then exports it as a UWP app.
Is it worth $3,000?
It's pretty cool. I mean, I will say, are you going to use it every day? No. But there are a lot of business applications that are using it on a daily basis.
Like what?
So Lowe's up in Mooresville is actually has a handful of them.
For which purpose? I used to work at Lowe's.
So they actually have a room set up that's basically like an empty kitchen, and what you can do is you can actually walk into the kitchen and go through and pick out your appliances, your countertops, your stone, and basically just do like real-time switch it to get an idea of what it actually looks like. From a training standpoint, a lot of maintenance work and stuff like that is being used with it, so that you can actually go through and, instead of saying fly somebody X distance under lots of cost to the engine overhaul repair scenario is kind of a big one, like with the airlines and stuff like that. Instead of doing the flying, I forget the ridiculous cost it is to do training for engines and stuff, but basically, you can, because you already have all the CAD drawings and that for the engines themselves, you can build those up in front of you and actually work on them hands-on. Case Western has a really cool sample that they show for doing like medical training.
Whitlock out of Raleigh did designs with theirs.
Yeah, there's a lot.
Some doctor in Atlanta with their hackerspace that did it to do a surgery.
Well, so one of the more interesting stories that I've heard is actually dealing with, take that off so I don't look as ridiculous, but that one of the things that I guess, most aspiring surgeons will actually, work on cadavers. Any doctors here? No? Okay. Well, medical doctor, but, and so, that they're actually working on the cadavers and whatnot, right? And you know, most med students are surprised during their first surgery that the person that they're actually operating on is alive, right? Even though they're under anesthesia, they're moving a little bit, right? But the cool thing that they're able to do with the HoloLens when simulating a surgery is actually show that movement, show that motion that, you know, most first-time med students had never realized before when working with cadavers and stuff like that. So there are a lot of interesting applications that, you know, just kind of scratching the surface on what they can do. But yeah, the price obviously is it is a concern. So for a lot of folks,
I would say I know Caterpillar is working, and I don't know if it's with the HoloLens or some other technology of enabling their technicians. Because of course Caterpillar has a lot of different equipment, but they can actually run through the maintenance checklist, and it uses image recognition to realize what model it is, what kind of equipment it is. Can bring up the PMs, can actually step them through a maintenance routine so that you don't necessarily have to be trained on every diesel engine they build. If you're a diesel mechanic and understand the fundamentals, the glasses can help you a lot.
And there is on this too, similar to that, there's like Skype integration with it, right? Where, you know, somebody, you know, if I'm here working on something, someone can be remotely showing me pictures and stuff like that from Skype to go through and point me in the right direction for stuff, which is pretty cool. Similarly, warehousing applications, you know, hey, you have, you know, this giant warehouse with a whole bunch of stuff on shelves where something located, you know, you can actually through like Bluetooth beacons, like weight beacons, and they call it poster tracking, but basically lead somebody through a warehouse to exactly where the item is on the shelf, you know, save some time trying to find stuff.
What's the
Cool
next
application.
technology that it's going to upgrade with, or what's going to be in part?
So what was announced back at the OpenCV conference about a month and a half ago is actually onboard AI processing. So the next version of the holographic processing unit can supposedly do some onboard AI as well.
Do we get underwear or t-shirts with our questions?
You get a thank you for your question.
How do the controls feel when you're using your hands and stuff? Accurate, or?
So you got to think about it very differently than your normal computer, right? You know, where I click in space has no relevance to where I'm actually clicking. It's where you're looking is what makes the difference. So where you look is where your mouse pointer is, for lack of a better term, and then the actual motion is executing that. So as long as you can hold your gaze where you want it to actually be, then where you actually tap in this space doesn't matter.
So you just mentioned it's monitoring where you're looking. Is it actually looking at your eyes and what you're focused
No.
on, or is it just where you're oriented?
Yep, it's where you're oriented as well as what the cameras are picking up.
Okay, and then another question. You've been using this more than probably 99% of more than that, like in the world. If you could improve or add one feature, like what would you think would make this thing?
The thing that's the biggest, one of the initial biggest complaints that a lot of folks have when they first use it is the field of view. I mean, it's not that it's small by any stretch of the imagination, but I think people are very used to the virtual reality experience where you're completely engulfed, encased, and that's all you get to see. Whereas this, because you actually are still able to see beyond that, you know, I don't think a lot of folks are expecting that. You know, and so they're expecting virtual reality, but instead they're getting this. For me, actually, though, having gotten used to that, the thing on my nose is actually uncomfortable. And it's,
How much does it weigh?
I want to say 6 pounds. 5 or 6 pounds, yeah. Because I mean, you got the batteries and all that stuff in it, right? But I have to look that up. I don't know the exact weight. But the thing is, I might even have it right now. I can't tell, but it digs in a little bit. So, I mean, I've worn it for 2+ hours straight without a problem. But you know, if I'm not balancing it real well, like it'll start. So that's my biggest complaint, having used it for as long as I have.
Once you hang on a 6 pound weight in the back.
Counterbalance it.
You're saying 1.3 pounds.
Is it 1.3? Yeah, it doesn't feel like that. It does not feel like that at all. So.
Why is the 5-second delay? Because the processing done in the back end somewhere?
So for the video, you mean?
Yeah.
So for the video, you can actually get that down to sub 1 second. There are APIs that'll actually hook into the media pipeline that will get it almost near real time. All of the samples that are hooking into it don't care. So they're typically running just like your standard 4 to 5 second delay, but it does take more processing to get that out real time or closer to real time, but it just, the ones out of there don't do it.
The processing done on the unit or like on the cloud? Or?
That's all done on the unit. Yep. It's a fully contained computer.
Self-contained.
Mm-hmm.
Okay.
Yep.
Is it Bluetooth to your phone? Or?
So that's wireless to the phone. Yeah, it's just for your standard mobile hotspot. But it does have Bluetooth too. Like I said, you can hook up Bluetooth devices to it. So, other questions about the HoloLens, about the project?
What's the direction? I mean, are they going to release something new?
I don't think future plans have been announced yet, so I can't really speak to that. You know, the big thing that just actually has released in terms of the overall mixed reality is the mixed reality headsets. That there's, I think, 5 in the US that are a lot more reasonably priced from that perspective. They're all similar to like the Oculus and the Vive in that they're tethered to whatever your primary PC is. But that's been where a lot of the focus has been recently, and those have just all started releasing in the past month and a half or so. And they're about... No. No, they're I want to say the current price tag for those is about $399.
Who bought Oculus? Amazon then?
Wasn't Oculus Facebook? Yeah.
But what you develop in Unity, you can export out to any of the platforms.
Yeah. Yep. So, so the app that I have, that's my Halloween scary app, will work on both the mixed reality headsets as well as the HoloLens. It's just a different. It's had to do a couple different things to actually have an environment in the mixed reality headset and know that I only have a 15-foot radius versus this that lets me cruise around the entire house.
But you can do export it out to cardboard or any of the $10 options, right?
Yeah, Unity will let you, as long as what you're doing is supported on that platform, would let you do pretty much whatever.
What are you using to connect it to the Azure, or how is it getting outside of the network?
So that's just, like I said, over the past year, I've been refining and reworking, and so I've been able to remove the service that I had that was actually, acting as like my proxy. So it's actually doing a direct connection to Azure using, I think, I was using HTTP. I think I've gotten it working with AMQP currently. I had to go double check what version I have, but what it does is it takes a lot of tricks in the editor to hide code from, so basically what I'll do is I'll hide code from Unity so that Unity will actually not crash when I try to run it. And then when it actually goes and builds the UWP app, basically kind of like if-defs the code so that it works for that. So I kind of have 2 versions of the app running. One version runs in the editor, and then a totally different version of the code runs in the actual application itself. So, any other questions? Cool. And if we have some time at the end here, we can maybe try to figure out if a few people, or maybe that'll be my prize, right? So we'll come up. 3 people tried out for a couple minutes. So. All right, cool. Thank you.
Hi, my name's Jeremy Proffitt. I'm a senior site reliability engineer at LendingTree. Really love the IoT field. Dan got me tricked into trying out some stuff for Alexa. And it kind of got me down this road where I found out the Particle Cloud actually has a lot of good capabilities. And I thought to myself, why are we hassling around with writing skills and doing API calls and doing all of this stuff when there's kind of a more elegant solution? And I kind of saw some people doing it, but nobody kind of did everything that the home automation skills would do. So I wrote it. So basically, what are home automation skills? So Amazon has basically two kinds of skills. One's a custom skill where I can give it intents and all kinds of words and everything else and phrases and I build out everything. And then there's home automation skills. The home automation skills are very, very structured. They are like turn on light. They are like make the living room blue. Or Alexa, set fun bowl to green. It might work. Alexa, set orange puck to green. There we go. So you can see that's just a simple interaction using a skill. And so I want to show you how that works. It's really simple. The first thing is everything is built on an Alexa skill. And that's what allows us to integrate between the Particle Cloud and Alexa itself, right? It does all of the translation for all of the JSON. It goes out, it discovers everything, and it's really kind of simple. It goes out to the Particle Cloud. It says, give me a list of all of the devices you have. And then it goes through each device and iterates through them and says, hey, do you have this special code? Do you have a name for me? What are your capabilities? And then it builds the discovery JSON and sends it back to Alexa. Once you add all the devices, you're going to next start out in the Particle IO IDE. This is real easy. It is literally 5 minutes to get up and running. You just go and click on the library. You're going to load my Echo Photon bridge. There's some samples here. The very easy one is light on off. And this one will turn the light on D7, the little blue light that's on the chip already. It'll turn it on and off, right? Very simple. The other one that I'll direct you to, there's a couple here. The Echo Photon Bridge test, this is kind of my go-to. This is what I use to facilitate the skills certification from Amazon. And it contains all of the functionality mapped out with the intents and everything. It's very easy to go through. I'm going to walk you through the code and what's required. And this is all that's needed, right? This is it. So I'm going to add my photonbridge.h, right? So I'm going to add my library. I'm going to create a copy of the library. I have a function for on-off. Has a couple of parameters. A device on-off is Boolean. Anyone know what that means? On-off?
It's what you put in soup.
Pretty. And then the string for raw parameters. That's exactly what it says. That's the parameters that are getting passed down from the skill directly to the chip. It's there for future expandability. We are going to use it in the next couple months as we build this out a little bit more. You can see when it calls the on-off, you can see all I'm doing is taking and writing to D7. If it's on a high, if it's off, I'm going to turn D7 low. Very simple. When I do my setup, it's about as easy as it gets. I'm going to add an Echo device V2 on-off. The name of it's going to be Photon Light. And when the photon light is initiated on the device, it's going to call the function on-off. It's a little bit funky for people who haven't done a lot of deep sea coding, but it's very easy to understand. Even better, there's a lot of examples. So, let me So this is, I'm going to walk through just setting one up. I'm going to go over here to my libraries, type in echo, echo photon bridge. You can actually look at the code over here if you want. This is my go-to, this is my test. It has fast LED already in it. Here are all the utterances that it'll support. So you can turn things on and off. You can turn colors. For example, Alexa, set orange puck to purple.
Okay.
Maybe. Alexa, set orange puck to yellow. There we go. Alexa, set orange puck to red.
Okay.
Very simple. Alexa, set orange puck to 50%.
Okay.
Doesn't like me tonight. Alexa, turn orange puck off.
Okay.
She really doesn't like me tonight. Yeah, exactly. The problem is that I've got the wrong code in that one. I've been playing around with code today. So I'm going to go ahead and reflash it with something that's a little bit more responsive. And I'm going to show you how easy it is to work with the particles. So this is where I'm at today. I'm working on the bowl. I'm going to pull up a prior piece of code. This is the one we used for the coding demo. I'm going to make sure our pin is set correctly. D6, gRGB, call it orange. How many people have worked in the Particle IDE? How many people like the Particle IDE? I think it's pretty awesome.
It's great that it's web and you don't have to worry about USB drivers or FTDI, this, that, and the other.
There's a desktop version now. There's a native version using Atom.
There's a real, yeah, it's really kind of new. It's not very mature. So it still has some problems, but it's not bad. There is a command line interface. You can do flashing and upgrades. If you're going to upgrade the source code, I really recommend the command line interface. It's just so much easier to do. You can see here I'm flashing the device. I'm flashing it with another set of code that I wrote for a different demo. And it should update here in a couple moments. Now, one of the nice things about this is that when I roll a new device, because the skill is already connected with the Alexa, with Particle, it automatically picks up new devices when I discover them. So I don't have to go and write something and go and do something in the Alexa console. I don't have to go change a Lambda. I don't have to go do this or that. I just roll my code, throw it out there, and run it, right? And then once that's done, see, we're ready. Alexa, Discover devices.
Enable the smart home skill for your smart device from the Alexa app.
So she'll go through discovery mode.
So you're not doing anything in Amazon's development side?
No.
I found 3 new devices. Try saying, turn off orange room side.
Alexa, turn off orange room side.
Orange room side isn't responding.
Yeah, apparently. So, give her a nice little reset there. When it's working, and it does work. It's actually real easy to get these devices up and running.
Maybe you should have Cortina.
Cortana?
Cortana.
Cortana's dead. Mike.
Did you consider the devices, since Amazon's Alexa is a RESTful API, phoning home
Sorry,
and...
I don't know that.
There's
your answer.
Since
You can stop now.
Since she's a RESTful API, the devices could actually use the internet and phone in to them with an API call to register instead of you asking Alexa to discover them the other way around?
Yeah, so it's kind of interesting. First off, none of this code maintains state, none of my code, which means it doesn't know what's out there, right? Anytime it wants to know, it goes and gets it from the chip. So the chip knows what it's capable of. It goes through the Lambda, and then it sends it off to Amazon. And Amazon is the state engine there, right? So it maintains state. Whenever, like you're talking about, it's possible. A couple problems. First off, home automation requires you to have an OAuth gateway and return an access token, right? And that access token is how it identifies you, your devices from my devices, right? And the Particle Cloud gives me that capability, right? So if I wanted to go from the Alexa skill to the device, I could. I would still have to have an OAuth component, right? And I could trick it, and I could do that with the chip. That's fine. But it's a little bit more difficult to implement. The other problem is that most homes are no longer publicly available to the internet. A lot of internet providers are starting to NAT the services in your home. Not all of them, but it's becoming much more difficult to get a direct connection from the outside world into your home. And that's really what's required to do that. If the chip could call out and report in, but then how does the command get back from where it's going from the Alexa cloud back to the chip?
So what I envisioned is that you could, you know your OAuth token for your Alexa. You can, Alexa's typically a Lambda function calling out from a skill, but it can be driven the opposite way too, because the user's account has a database that's associated with, you can call into Alexa with a RESTful call as well. So you can trigger that Lambda function not from Alexa, but from another REST call into the Lambda stack.
Right now, it's definitely possible to do. The problem you run into is maintaining of state. So I really don't want to maintain any state, right? I'd have to have a database. I'd have to have some kind of state engine, right? This can all be managed without state. So I don't have to have a stateful engine. I just manage a request coming in, a request going out, requests coming in, and I just manage the interaction, right? I don't have to maintain any level of state. I don't have to know who you are. I don't care. Amazon sends me the token whenever I want to activate a device. The token then gets passed on, and comes back through. So from a development standpoint, it's a lot cleaner. It's also a lot more automated back and forth, easier to manage. Other questions?
We're going to get t-shirts?
I've been 5X. What do you wear?
It's a t-shirt, not bed sheet.
It's funny. There's a really good talk on this on the Charlotte IoT that I gave for the bots meetup, and in those, the demos actually work. I've been playing around with code all day, so I'm surprised that they work this much even.
Demo works every time it's a product, ship it.
I could be Microsoft with this stuff up here. Any other questions?
Does this code work with any other development boards like ESP32s?
Good question. No. Because the ESP32 doesn't have a cloud component, right? So you would have to, and this is one of the reasons why I love the Particle for this particular application. You would have to build out an OAuth server. You would have to build out an MQTT client with state, right? You'd have to build out a user management system, and you would have to build all of that out. You would have to keep it secure, and you'd have to pay for it. Instead, I buy my devices for $19 a piece. I throw them on the board. In 10 minutes, I'm up and running, and I'm done. So that's why. I know people want to play around with MQTT. I've played around with it before. I'm not impressed for small runs, for developers. You know, I just want to get stuff done. I don't want to sit there and play DevOps and build out servers and the whole bit all day long. I just want my stuff, I just want my lights to blink.
I code like one thing a year, and I had an idea after seeing your presentation, and I hacked my daughter's Eeyore at dinner in 20 minutes and had it, you know, Alexa and Google and text messages and everything controlling it in 20
I'm
minutes.
not quite sure how to help you with that.
It's not always about you, Alexa.
She certainly thinks so. Cool. Any other questions? I'll put the documentation out there. If anyone's got any questions, feel free to email me. We've gone through a couple iterations, fixing some bugs. Obviously, might have to do some more. But she's pretty solid, actually. We put this in at Sean's house, and we had real good luck with it because we didn't play around with it or try to do anything really too advanced with it. And we were using it this weekend for the remote. And it was working, except it was having a problem returning the temperature. So.
Can you show and tell your bowl? I think you missed something that's pretty epic, that you designed these things for this. Can you show them off a little bit?
Alexa, set fun bowl to green. Let me reflash it.
Or just the design and how...
Yeah, so ADA fruit, which, by the way, if anyone in the room doesn't buy from ADA fruit, I would suggest you do every once in a while because they really do support the community really well. They have a lot of libraries out there, and if you've ever played with Arduino stuff, you've probably used their libraries. A little expensive, sure, but definitely worth going and getting something from them once in a while. They have a $25 board that a particle can be soldered onto that has 24 neopixels. And those neopixels, so I'm just checking the code to make sure it's what I want it to do. Those neopixels, are just in a circle. 3D printed a case for it. Took a bowl, built a holder for it in there. Just something fun, something different. It's flashing. You can see it flashing now, and it's updating the device.
And how quick is it to work with this fast LED?
Fast LED takes a little bit of getting used to. There's a ton of examples out there It's really easy to manage once you get used to it. Basically, you access the LEDs in an array. So LED 1 is 0, you know, and so you go all the way through. You're supposed to be able to set,
255.
let's see if it's back up. Devices. This is a cool thing about the Particle Cloud is that I can go in here and I can look at my device, look at my functions, and for some reason she's not returning anything. Okay, there it is. You can see this is actually what's being returned from the chip. One of the reasons that we have this interface between the two is basically that this is what's coming back from the chip, right? Very simple string. What has to be returned to Amazon is a JSON this big. And we really don't have the capacity to send that back from the chip, so that Alexa skill acts as an intermediary. Alexa, discover devices.
Starting discovery. This will take up to 20 seconds. If you haven't already, please enable the smart home skill for your smart device from the Alexa app.
Alexa's got a lot of really interesting things going on with her. There's an online version of the app that allows you to look at your different items.
I couldn't find any new smart home devices. If you have Philips Hue, press the button on the bridge and rerun discovery.
Alexa, set Fun Bowl to green. There we go.
Okay.
Alexa, set Fun Bowl to red.
Okay.
Alexa, set Fun Bowl to blue.
Okay.
Alexa, turn off Fun Bowl.
Okay.
Yeah, she didn't like to turn off. Anyways, I'll fix the code anyways. That's a coding issue. But it's so simple to program in and get up and running. If you have any questions, feel free to reach out. Huh?
It's got the wrong Boolean. It's got the soup Boolean rather than the mathematical Boolean.
Any questions? All right, Mark, take it away, my friend.
human experience and simplify life. What is the Internet of Things? Is it hardware, software, or both? Well, chances are you already have it in your pocket. It might be on your wrist. Recently popular are fitness bands with accelerometers and gyroscopes to monitor our activities and heart rate. Now we have smartwatches which do all of that, play music, and they can answer messages. Smartphones and tablets have replaced maps, secretaries, alarm clocks, entertainment, and now they can control our homes, change the TV, the temperature, security, and lights all from your device. Our cars are even getting smarter with sensors to keep us safe. The Internet of Things is simply using technology to mimic the human experience and simplify life.
Good evening, everyone. My name is Mark Ingle. I'm an IT director at Comport Communications in Rock Hill, South Carolina. Been involved with this group for about, I don't know, maybe over a year now, and I have learned a lot. I don't profess myself to be a developer or engineer of any kind, but I hang around people who are, and they kind of make me feel like I am. So if if this is your first night here, I encourage you to get involved with this group. A lot of good people to hang out with. So I'm really excited about this talk. I had a lot of fun with this project. I learned a lot. I'll show you some things tonight in Fusion 360 that I did not know until I started with this project. And just for the agenda, I want to talk about the idea to concept to reality, because that's basically what Dan and I did. Started with an idea, I think a family dinner or something like that, and we talked about how we could possibly do it. And then with the open source things that we have available to us today, which I just think are amazing tools, we were able to produce what we call our bubble fogger. So, and then I'll talk about the challenges, and then hopefully I'll be able to show you some interesting things in Fusion 360. So a little bit about the idea. Dan, it was like a dinner conversation, right?
Yeah. My son's girlfriend actually said fog bubbles would be cool.
Yeah. So, and then after one of the meetups, Dan said, "Hey, you do 3D printing and you do design. You want to help me design this thing?" And I said, "Sure." I love and get involved in some of these projects. So, but the goal was to make an amazing bubble fogger for Halloween to thrill kids, and you'll see some pictures here in the next slide that we did that. But like all projects like this, things you want to do, you have more questions than you have answers, right? So just a couple of questions here. All these questions that came up was, what's out there? How do we power it? How do we make it? What makes the smoke? How do we blow the bubbles, right? You got to be able to do that. It's pretty important. And then how we get it to fit in the mask. Dan wanted to have it in a mask that he was going to hang from a tree. So what's out there? The first thing I do is, when I think of an idea, is, well, what's out there? Do I need to make it or do I need to buy it? Turns out there is a bubble fogger out there. If you got $100, you can go buy it. But it did not necessarily meet all of our requirements. We wanted to do something specific with it. So, but it was a good jump start, I think, into the concept that we needed to consider in order to pull this off. So this is us meeting our goal, right? Drilling the kids. And Dan's not running a daycare or anything like that. These are the kids that showed up at his house. And you can see over here on the right, he's got the bubble fogger with the cat mask on it. And if I had seen this as a kid, maybe I would be an engineer, That is just so cool. So they're popping the bubbles with their sword as they're coming down. And then he's got all the kind of other stuff that's in the yard too. But I feel like we accomplished our goal of putting this thing together. Do you want to do a demo?
This was like 10 times more fun than all of my other projects because I got to work with you, Mark.
Oh.
And doing the iterations and everything was just like amazing. But I'll demo the cat. Alexa, ask Spooky Kitty to make fog bubbles.
Make clog bubbles.
Pretty cool, huh? I don't know if you could tell it, but they were landing on the floor and just sitting there and busting. So, and there's one still there. Yeah.
Me clog bubbles.
Alexa, exit. Yeah. So, I didn't think about smoke alarms.
Yeah, we're good.
Okay. Yeah, and so I had one as well at my house. I was burning up my FETs for some reason. I never could figure out why. But I had mine in a Frank mask, a Frankenstein mask, and I called him Frank. And what was really funny, and I don't know what Halloween is like at your neighborhoods, but you know, there's a lot of parents with liquor and coolers pulling in wagons and stuff like that. And one of the kids asked Frank to blow bubbles, but Alexa thought he asked what flashulous is. So Alexa started to explain what flashulous is, and just everybody just started dying laughing, you know. So yeah, so it was a hit with the parents then, and then they were asking everything to Alexa, you know, and then Alexa would say, you know, okay, and not do anything, and a couple of guys responded, "You're just like my wife," you know, that kind of thing. So it was a real hoot. All right, so from the idea to concept to reality. So these questions, these are the questions, and these are kind of how we answered them. How we're going to make it, of course, we're going to use a 3D printer. And one of the things that I think 3D printing does for us these days is that it really fuels the ability to do rapid prototyping. And you'll see some of the things iterations that we went through. Photon controlled, some of the stuff that Jeremy was doing is exactly some of the stuff that we did. In one of the pictures, you may have saw the pumpkin on the 20-foot tall frame that Dan had built. We just used the code from that and modified it to meet our needs. Took a lot of power, 4 3.7 volt batteries, 4,800 milliamp hours. And these are really fantastic batteries. I didn't know they existed. They last a long time. And then the 2 MOSFETs, one for the fan and one for the vape. So we actually used a vape device. You guys seen these folks, people who go around actually vaping? Well, they're holding 200 watts in their hand, and they're putting it up through their mouth. I didn't realize that until I got in this project, and I was like, you have got to be kidding me. So they're sucking on the light bulb, right? And it worked really well. You just saw the smoke that this thing put out, and it really punches the power to it really quick. So how do we blow bubbles? So I hadn't blown bubbles in 50 years. So I actually went out in my yard with a bubble wand and started blowing bubbles, and people were walking by and like, why is this 50-year-old man blowing bubbles in his yard? You know, so, but I had to do that because I just couldn't get in my head, how do we blow bubbles with the design that we were coming up with, and something that kind of matched up with what that commercial product does. We started with a 5-volt van, 30 millimeter 5-volt van, and it wouldn't do it. Tried the 40 millimeter fan, and it would not do it. We ended up, and I'll show you a video how I tested it. I ended up with a 40 millimeter high-speed fan. These are the fans that you see in the back of servers, these things that push a lot of air. Matter of fact, the testing that I did, I found that I needed at least a fan that would do 27,000 CFM, and it could not be any less than 12.4 volts going to the fan. If you had any less than that, you just got a big long blob bubble out there. You wouldn't get a steady stream. So
CFH or CFM?
CFM is what was on the fan rating. Yeah. Well, in the video, you'll hear how loud it is. It sounds like a jet engine. So, and you'll understand why in a minute when I kind of show you the challenges we went into. And then how does it fit in a mask? I just went to CVS and found the Frank plaster mask that I kind of based it off of. So blowing bubbles, we started with a flexible tube here. And I thought this was going to be the answer, but it was not, because the problem is when you dip it down to get the bubble juice on it, if the fan is blowing, you start making suds. So it's because it's blowing while it's in the bubble juice. So this did not work. But But from a design perspective, 30 minutes of design work in Fusion 360 and about 40 minutes of 3D printing. So not too bad. Use fans to blow the bubbles. Yeah, like I said, well, it's not that simple. Well, it turns out that when people use these vapes, they're sucking the air in. So the way these things were designed, there's really two small vents, about an inch long and maybe an eighth of an inch wide, and they're on either side of each other. So in my mind, when I first started with this, I thought, well, we just kind of have to blow air in a tube. Well, that's not what we're going to do. So what I had to come up with was a way to pressurize the fan mount in such a way that it starts pushing air through the vape. So it wasn't about blowing air, it was about creating enough pressure so that air would flow out of the vape. And this is a video of what I sent to Dan.
Okay, Dan, I wanted to show this to you real quick. We've got to get down the road here in a minute for a birthday party.
And I'm not going to play the whole thing.
What I've discovered is that...
is that showing up okay?
I thought these
no,
fans
I
would
don't.
be enough to push air through the vape, but there's just not enough. They don't have enough power to push the air, enough air to blow bubbles.
So that's the, I'll pause it right there. That's the first fan mount that I made with for the 5 millimeters, and it didn't work. But maybe 20 minutes of design work, and then I think it took maybe an hour to print it. So, let's see. So this is the fan mount that ended up being the one that I went with. I thought I needed 2 fans, but with these high-speed fans off the back of the power supplies, they push a lot of air. So I just plugged up one side of it.
You'll see it. See what I mean?
And then, so this little test that I'm doing is, I just wrote a little quick Arduino program. And what it's doing is it's ramping up the PWM by 5, starting with like 30, I think it was, for a PWM. So it starts out really low, and I wanted to know when does it start blowing the type of bubbles that I want. And while it's doing that, it's just doing serial output to tell me what the RPMs are as it's running. So
that just increases the PWM.
Move it forward.
On there, so I'll let it crank up a little bit.
And it gets so loud you can't even hear me. So you can hear it ramping up. And as it ramps up, I'll put the bubble one in front of it just to get an idea about when it's going to start getting louder.
So there's some big bubble.
So that's not going to work for us. There it goes. That was at 2,700 out there.
Full speed.
But more is better, right? So 27,000. Yeah, sorry. So it's really kicking it now. And I'm getting pretty excited about it.
Yeah.
So that's how I determine what I would use for.
And then just reset that.
That's how I determine what I would use for a fan mount. And lost my place here. So the next one, you use a common Halloween mask. This is the Frank mask, and it's hard to tell from here, but you can see the platform sitting inside the mask, and basically the mask is almost pear-shaped, if you will. So I knew that it was kind of the shape that I needed to make the tub that the bubble juice is going to be sitting in. So. Oops. And then
go on Shark Tank and sell these for Halloween and other events.
Oh no, yeah, we'll see. Maybe we'll put it out on Hackster and just draw some attention to what we're doing. But yeah, it's a pretty cool project. So the next thing I want to cover is you don't need to always design and engineer something. There's stuff that's available to you that you can use to get the job done. So it turns out that there must be a science to making bubbles, because I could not design an end that would dip in the bubble juice and blow bubbles. I probably spent a day doing that. And then what I discovered is that as I was sitting there looking at the bubble wand, I was like, well, heck, why don't I just cut this thing off, design a hole that's recessed and just fit it inside there. So that's what this is. I don't know if I can get it out. It's not 3D printed. It came from the bubble wand. So that's, when you look at these are parts down here for you guys to look at after the talk. But you'll see the opening for it. And when I get into my design, you'll see kind of how I did the threading for this. These guys actually, and it's a fine thread because I knew we needed to make small adjustments to get the end of the bubble fogger just at the very end of where the tub is, because when it drips, it needs to fall back in the tub. But we wanted to have it extended out enough so that we could have clearance for our mask. So the really cool thing about Fusion 360 is that it's really easy to put threads, the male and female threads, in whatever you're printing. But this screws in really tight, and it's easily adjustable. So let's see. Now we want to do Fusion 360. You guys see that okay? So what you're looking at is the design, the final design that we ended up with, and it's that black piece that's sitting over there. And Fusion 360, it's a hosted solution, and I was lucky to get it really cheap. I'm not sure how much it is now to sign up for a license for it, but I got it for like $80 for 2 years. Started with a demo version and held out on the marketing stuff that was coming around, and ended up with that kind of offer. But it works really well. There's several modes in it. I'm in the modeling mode right now. There's also the patch mode that's more similar to Blender, if you guys are familiar with Blender. That's where you go in and you can kind of virtually mold a shape that you might want. But what for Dan and I were doing, we had specific requirements on the size and the shape of what we're wanting to do. And what you're looking at here is just where we ended up with on some of the iterations. I mentioned there's the bubble end that I felt like I needed to make, right? But it wasn't, I didn't need to do that. So I designed something a little bit easier. That's this guy right here. I'll pull that up. So this is the end of it, and you can see the threads that are there. And one of the things that I discovered was that I needed a way for more bubble juice to hang around the end of the spout. So what I came up with was using what's called an extrude and Boolean cut, so to speak, is what it is how I made these holes in here. And then Fusion has something called webbing that allows me to create a cavity in here. And what happens is the bubble juice or the bubble wand dips down, and explain it with this one. The bubble wand dips down, and with that hole on the top, when it comes back up, it has a little reservoir of bubble juice, and it falls outside of those. It falls outside of those little holes that you see there. And this is one without the reservoir, and it made a difference of like 3 to 4 more seconds of bubbles, and larger bubbles if we needed it. So having the ability to pull the, I guess this end of it out into a separate drawing allowed me to do that without interfering with the work I'm doing on the main drawing. I mentioned the fan mount. So this is the 40 millimeter version. I started with the 5, but I really didn't have to change a whole lot other than edit the sketch to change the sizes there. You see on either side of it's actually made it 41 so that I'd have a good seal around the fan. But all I had to do was go in here and change these values. And after I did that, stop the sketch, I have this now in a 40 millimeter version. So you can see how that really facilitates the rapid prototyping that I'm talking about, where you try something, you think it's what you need, you actually try it and it doesn't work. You don't lose a whole lot of the work that you did initially to get the design done. You just go in there and change the actual measurements and it recreates it for you.
It reconnects the webbing or it reconnects the mesh?
Yeah.
We're using 1 or 2 fans?
We used one. This is it right here. Pass that to him. So that's what I found in my testing, was I only needed 1 fan. So the bubble ring, this is pretty cool. So this is where I was attempting to make my own bubble ring when I really didn't need to. But it was really easy to do. That's one of the things I wanted to show you here today. The cool thing about Fusion 360 is you have this timeline here, and I can bring this drawing back to where I started, which is nothing right there. Edit the sketch, that's what I started with. So I just brought it back to where I was at, and if I wanted to, I could add something in between that feature and the next feature that I'm going to draw.
It's all parametric, is what's cool about it.
Yeah. I'll show you an example of that in a minute. So for designing this, all I had to do was to create a sketch of one of these little slices of, I call it a pie, slice of a pie, right? Designed it to match one of the bubble wands here. And then I use this feature called parameter pattern. And what it does for you is you tell it what the sketch is that you want to replicate, you tell it the path that you want it to follow, and then you just tell it how many of whatever you want, and it pops it in there for you. Pretty cool feature. Does that make sense?
So now you have to be connected to the internet to work this?
No, you do not. But the tricky thing about Fusion 360 is when you are not connected to the internet and you leave your laptop and you go to your workstation, that workstation is going to have the previous version before you started. So you have to be careful about saving your work. And if you're not connected, when you start it up on your workstation at home, what is your connection status? And what does it know what version you're on? Because if you start designing, you're going to end up with version conflicts. And I've done that several times. So you have to consciously remind yourself when you start up, what's the state of my connection? What version am I supposed to be on? And what does it recognize it's there? So, was that correct, Craig? Did you say parametric? Yeah, so it's parametric. And so this is an example of that. In here you can actually create parameters that have values. And what I'm about to show you is kind of how I did the tubing for it. You actually create what you think the values would be. And I've done enough of this to know what my spacing needs to be. That's what this value is there. And when you do threading, you have to make sure that your pipe is thick enough. And I know I really can't do anything less than 5 millimeters. So with that, I'll close that, and I'll start a sketch. When you start a sketch, you have to start it on either a plane or a face. And for tonight, I can get it oriented. It's oriented. So for tonight, I'm going to start on this plane here. And if you know you're going to be printing an object, it's best to start on the XY plane because the Z-axis prints up on a 3D printer. So
Remind me to show you my 3D mouse.
Okay.
At the end of this, it'll change your life.
So I'm going to do a circle. And for that circle, I'm going to say inner diameter. Zoom it in a little bit. I'm going to plop that out to the side. And the shortcut of C for the circle again. I'll bring it out, and I'm going to do male outer diameter. And now I've got what is the starting of the male tubing. And with with Fusion 360, Blender has this too, but there's something called extrude. And extrude is basically just taking a sketch, selecting what you want to extrude, and I'm going to show you how to do this. This is hitting E, and then pulling it forward. So that would create a cylinder for me, but that's not what I want. I want to do this guy, and make sure my orientation is right.
Can you knurl the ends? Can you add a fillet?
Yeah.
Okay.
Yeah. So I'm going to bring this guy out and just do something random here. And if you notice over here, I just created body. Now it knows that there's an object in this drawing. If I wanted to export it as an STL and print it, I could. But right now, Fusion 360 recognizes this as just a kind of an object, a body. You can't apply all of the Fusion 360 features to it. In order to do that, you have to make it a component. When you make it a component, you have access to all of the features that come with Fusion 360, and I'll show you that in a minute. So for the female piece, like I said earlier, you have to start against a plane or you start against a face of an object, and this is a face. So I'm going to start a sketch there. You can see how it kind of gets tinted right there. That means that it is a sketchable surface is kind of how I think of it. So I'll do C, create a circle, and there's some helpers in Fusion 360 that are really beneficial. See how it locks in and turns green? That means I'm centered in on that dot. And that was really helpful for this thing because one of the things I had to do was to keep the vape and the tubing aligned all the way across. And even when I designed the spout, it needed to be aligned so that when it comes up and locks in, you've got a straight alignment and it seals up really tight. So having this feature here allowed me to do that. So for this, I'll do, let's see, female, enter. And if you notice, you see the little gap there? That's the 0.5 millimeter that gives me the ability for it to slide in and out and put the threads on there. And then see again, female outer. And now I've got my female tube, and I'll just extrude it. Whoops, I just lose it. Cancel that. Extrude that out. Okay, and now I've got another body there. So, since we're getting late here, I'm just going to show I won't do it, I'll just show the thread feature. So you select the thread, you select where you want it, and then you have to tell it that you don't want to do full length. And then you just make your adjustments there. There's all kind of thread standards. I didn't know there were so many thread standards, but you just select your thread, and then if you want to see what it looks like, you model it, and then say OK. And then there's your thread. And you do the same thing for the female thread. You just select the inside of it.
Where do you work again? In Raquel? Where do you work?
Rock Hill. Comorium Communications. Comporium Communications. Yeah.
Doing nothing to do with 3D and nothing to do with that.
Yeah. So I want to show you how let's see. So what I didn't show you earlier was, I'll do a different type of joint, but so I needed to know whether or not this worked from a mechanical standpoint. The other cool feature about Fusion 360 is you're able to do motion with it. You're actually able to see parts work. And that's the thing that I learned in doing this, because when I started designing, I was like, oh shit, this stuff has got to work. You know, if it locks up or something like that, you know, it's going to be a big waste. So I don't know, maybe 2 YouTubes later, I understood what I needed to do.
And if you guys want to learn this, Instructables has a new course that is like, here's how you open the program all the way to making something.
Yeah. So it's not, let me highlight it a minute so you can kind of see it. So I just highlighted the joints that I created. These are movable joints, mechanical joints that have mechanical restrictions, and they only operate a certain way. Those are kind of parameters you put against the joints. But what it allowed me to do was, as I was designing this thing, I could go in here and actually move it and see the, let me turn the tub off and the stand. Okay. So now you can see in doing this, I'm able to confirm that my parts are working correctly and that when I print them, they should print. And the other thing that it did for me is for this shelf, I needed to know what kind of clearance I needed for the back end of it. You see that spot there? I needed to make sure that the length of my arm wasn't going to hit up against that back corner. And when I originally designed it, this arm here was too long. I kept running into the back of that. So
does it simulate the binding of that too?
The what? I couldn't hear you.
Does it simulate hitting that too, or does it just like go into the?
Yeah, it can, but you have to like enable that feature, which, you know, I don't. It's probably some of the more fancy things that people will do would want to have something like that.
It's got some interference checking. Where
Yeah.
You can tell it to check if parts are overlapped or that sort of thing.
Yeah. And there's movement analysis that it does and that kind of thing to to understand how many degrees are each of the joints moving and that kind of thing.
There's a ton of structural analysis too.
Yeah, yeah. So, but having this feature there, it showed me, hey, this thing is too long. When you print it, it's not going to work. So this was really beneficial in helping me understand from a mechanical standpoint how this thing needed to work.
Did you had to cut the tubing at an angle so it would clear when it pivoted? Made the pivot, I guess I should say. How did you know to make that cut the way you did it?
Trial and error.
Trial and error.
Yeah. Printed.
So the first one didn't move because it had
Right.
interference.
Yeah.
Are you exporting an STL or can this slice also?
Say that again, STL and what?
Are you exporting an STL file from this into your slicer or can you print from here?
You can print from Fusion 360, but I've not paid for that feature yet. Yeah, so what I do is,
It'll go through an external slicer. And basically you can tell it, you can integrate a slicer with it, and you can click on like export to a 3D printer, and it will go through slicer or whatever, and then actually slice it and print it from there.
Okay.
I don't know that I'd want to print from anything but S3D anyways.
But is S3D integrated into this?
No.
Because that'd be great if S3D had a plugin for Fusion.
Yeah, they might eventually.
Because, I mean, this is becoming the Kleenex of, Maker 3D.
Right, yep. So, and the other thing that was very helpful was You can see some of the similar parts over here on the side. One of the features is you have the ability to create a separate drawing in your project and then import that drawing into your main project and place it where it needs to be and kind of block it in for the design. So that's what I did with this guy. You'll notice that, so this is where I built an exact replica of the fogger. That device is
Are
actually...
these files being stored in the cloud or locally?
They're in the cloud. Yeah, they're in the cloud. You can export them as an archive, I believe.
We'll pull them locally. It's like a source control. It actually uses, I think, a version of Git, because you can branch your designs and actually merge your changes back together. And each of your parts can be versioned separately from the rest of the main component.
Wow.
Yeah. I think that's a paid, you have to pay for that, don't you?
It's even in the free one.
Is it really? Okay.
You're limited to how many you can store.
Okay. Yeah. You can see what he's referring to up here. I don't use it anymore. There's the master branch right there.
That's awesome.
So, yeah. So I think that's it. Anybody have any questions? Yeah. All right, guys. Thank you.
Oh yeah, we have to give a prize. I almost forgot.
Actually, you want to close out the live?
Alexa.
Yeah, we'll go ahead and close out the video. Thank you everyone for watching Charlotte IoT tonight, and we're gonna give away some awesome prizes, but you won't see who won. So.
What is the Internet of Things? Is it hardware, software, or both? Well, chances are you already have it in your pocket. It might be on your wrist. Recently popular are fitness bands with accelerometers and gyroscopes to monitor our activities and heart rate. Now we have smartwatches which do all of that, play music, and they can answer messages. Smartphones and tablets have replaced maps, secretaries, alarm clocks, entertainment, and now they can control our homes, change the TV, the temperature, security, and lights all from your device. Our cars are even getting smarter with sensors to keep us safe. The Internet of Things is simply using technology to mimic the human experience and simplify life. What is the Internet of Things? Is it hardware, software, or both? Well, chances are you already have it in your pocket. It might be on your wrist. Recently popular are fitness bands with accelerometers and gyroscopes to monitor our activities and heart rate. Now we have smartwatches which do all of that, play music, and they can answer messages. Smartphones and tablets have replaced maps, secretaries, alarm clocks, entertainment, and now they can control our homes, change the TV, the temperature,